Hello everybody, hopefully we're having a great day. Yeah, I'm probably sitting on the beach somewhere, having a great time. But I miss you, of course I do. Okay, so let's get started. Hopefully Mr. Fredericks has passed this worksheet out. If he hasn't, we can pause and have him pass this out. Okay, activity 7.4. Okay, so let's take a look at this square. It's a square that's 1 by 1. So right off the bat, I already know the area. The area of the square has to be 1. But let's take this square and let's cut it up, okay? So let's make 5 cuts and list the partial sum. So if I cut the first one right in half, I'm going to go cut it right in half. Boom. There's cut it right in 1/2. Then this side here is 1/2. That's my first partial sum is going to be the 1/2, okay? And then let's take this half and cut this in half. So I cut that in half. So my first cut is 1/2, right? Okay, so then I'm going to cut the other piece in half, and that's 1/4. Okay, so plus 1/4. Okay. Then I cut what's left over. I'm going to cut that, what's left over there, in half. So I'm going to cut that in half. So, all right, cut that in half. So I'm cutting 1/4 in half. So obviously that is 1/8. Okay, that's plus 1/8. Let's cut that in half. Half of an eighth is a 1/16. Let's see, I've done 1, 2, 3, 4. So I'm going to add my 1/16. And then I'm going to cut my partial. So I'm going to cut this 1/16 one more time. Cut that in half. I'm going to have a 1/32. So I'm going to add in the 1/32. Okay, so I'm going to take my square. First I cut it in half. Then I took the half left over. I cut that in half, and that made a 1/4. Took the 4th that was left over and cut that in half. Got an 1/8. I took the 1/8 that was left over and I cut that in half. I got 1/16. I took the 1/16 that was left over and I cut that in half. Got 1/32. Okay, and of course I can keep cutting and cutting and cutting and cutting and cutting, which I will. Now it talks about the partial sum. So first of all, my first sum, S1. This is S1. Okay, S1 is just 1/2. Okay, so area, let's see. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Let's make that 1. So that means this is 1/2. 1, 2, 3, 4. There's my 1/2. That makes up my 1. My 1/4 is there. 1/2 is there. 1/4 is there. That means this is 3/4 there. 7/8. Okay, and we can even use decimals if we want to. Okay, so my first partial sum. This is my area. So the area is just 1/2. Boom, we're just going to go 1/2. There it is, right there, okay? Now, my second sum, S2, is to add the first two, okay? So it's my 1/2 plus my 1/4. So if I add my first two sums, I'm going to add 1/2 plus 1/4, which makes 3/4, okay? S2 is 3/4, okay? So my second sum is 3/4, which is right there. Okay, my third sum, S3, my third sum is to add all three of these. That's my 1/2 plus my 1/4 plus my 1/8, which makes 7/8, okay? Let's see, my third sum is 7/8, which is right there, okay? My fourth sum, S4, let's see, is all three of these. That's 1/2 plus 1/4 plus 1/8 plus 1/16. So if I add them all up, I get 15/16. Okay, so 15/16 is right there. Okay. Now, my fifth sum, S5, is going to equal all 5 of these. So if I add 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, I end up with 31/32. And if you don't believe me, you can do the math, okay? So my fifth sum is 31/32. Okay, so now if I take a look at my graph, okay, and this is areas, right? If I just keep adding piece after piece after piece, what's happening is my area is approaching 1. Okay, Because if I go back to my piece and I keep cutting, cut, if I keep cutting and I keep cutting and I keep cutting, I keep getting more and more pieces, pretty soon the pieces that I keep adding on are so small that they're hardly even big enough to make much of a difference. But if we can cut forever, all the way to infinity, if there's such a thing, then our area has to be 1. Our answer must be 1. We know the answer is 1 because we know the square has a size of 1. If we add up all of the pieces, we know it's going to be 1. Okay, so in a sense, we can add something to infinity, okay? So, if I keep adding all my partial sums, then my partial sums is just going to equal 1, all right? So, let's move on. This is an infinite sequence and an infinite series. In order for anything to be an infinite series or sequence, what we want is for the multiplier to be less than 1. We're going to see that in a second, okay? All right, so if you need to pause it right now, go ahead and pause it. You need to grab your journals, okay? Go ahead and grab your journals. Okay, hopefully everybody's back. I want you to go page 212. Let's go to page 212. Okay, everybody on page 212? All right. So, the sum of an infinite geometric series. So first, I'm going to highlight this word, geometric. Has to be geometric. Has to be. If it's arithmetic, it won't work. Okay, I'll give you an example. If I add 5, add 5, add 5, add 5, add 5 forever, if I keep adding forever, we're just going to go to infinity. But an infinite geometric series can work if we are multiplied by anything that's less than 1. So R must be between -1 and 1, okay? If R is bigger than 1, it has no sum, okay? Example, okay? Let's take our 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus dot, 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 okay? Write that down, okay? So, if we were to add all of these up forever, the very last piece would be so small that it would make any difference. This will have a sum. This will have a sum because R is 1/2, which is less than 1. So when you multiply by less than 1, the thing's going to get smaller and smaller and smaller. That's true. Okay? So this has a sum. Has a sum. In fact, the sum happens to equal 2. It really does. Happens to equal 2. Okay? Other example. Let's say we went 1 plus 2 plus 4 plus 8 plus 16 plus 32 dot, 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 dot. Okay? If we're to add forever and ever and ever to go to infinity, then the last piece will be so big it's going to be infinity. This has no sum. Doesn't have a sum because if we add them all up, our sum is infinity, and infinity is not a number. Okay? Infinity is not a number, so it has no sum. So what has to happen on today's lesson is when you multiply by something that makes it smaller and smaller and smaller and smaller. The way we know that is geometric, and R is going to be less than 1. Okay? Now, how does it work? Well, we have a formula. So if it is geometric, and if R is less than 1, or between 1 and -1, then we have a formula. S of infinity, in fact, I like to write the little infinity here. S of infinity, they should have. S of infinity is equal to A1, first term, all over 1 minus R. And again, R must be between -1 and 1. -1 is less than R, which is less than 1. Okay, R's got to be, the multiplier's got to be a fraction or a decimal between -1 and 1. Okay, so let's take a look. Let's shift the page over. Let's look at problem number 1, and let's use our formula. So our formula was S of infinity equals A1 over 1 minus R. Okay, now I'm not going to graph it. I just want to find the sum. All right, I don't need to graph it. We've done that already. So let's figure it out. So if I look at this, it looks to me as if we are getting smaller and smaller and smaller. At least I think so, right? So if I went 1/4, 1/6, 1/9, 2/27, it looks to me as if, let's see, multiply up by 2, 3, 3. Looks like I'm multiplying by 2/3. I believe R is equal to 2/3. Multiply that by 2/3. Multiply that by 2/3. But just starting right here is multiplying by 2/3, okay? So, if R is equal to 2/3, my first term is 1/4. Let's use our formula to find out what's going to happen, okay? So I'm going to go S of infinity is equal to our first term, which is 1/4, divided by 1 minus 2/3, okay? I'm going to use my formula. S of infinity is equal to A1. My first term is 1/4. My multiplier is 2/3. So I'm going to go and simplify this. I'm going to have a 1/4, and I'm going to divide that by 1/3 because I simply went 1 minus 2/3 is 1/3. When I multiply fractions, I'll have a 1/4. I invert and multiply, right? 3/1. So if I were to add all these terms up to infinity, my answer would be 3/4. Okay, let's do the next one. Okay? So number 2 seems to be as if I'm multiplying by 1/5 all the way. Okay, if I multiply 3 by 1/5, multiply by 1/5, multiply by 1/5, multiply by 1/5, multiply by 1/5. So I know that R, which is the multiplier, is 1/5. Okay, that's going to be good. It's going to work. So let's use a formula. S of infinity is equal to A1 over 1 minus R. Okay, that's our formula. Okay, so let's add these to infinity. S of infinity is equal to A1. The first term is 3 over 1 minus our multiplier. Our R is 1/5. Okay, let's do some fraction magic. I'll have 3 divided by 4/5. 1 minus 1/5 is 4/5. Invert and multiply, that's 3 times, if I flip the fraction, 5/4, right? I flip the second fraction, makes 15/4, which is, let's see, 4 goes into 15 3 times, 3 and 3/4 would be my sum. If I were to add all these up to infinity, I'd get 3 and 3/4. Okay, how am I doing? Hopefully I'm doing fine. You can always pause the film if you need to. Okay, turn the page, all right? Now, how about number 3? Okay, now number 3, it does say it's going to infinity. Check it out. We're going to go 1 to infinity, 6 times 3/5 to the n minus 1 power. Now it really is in the perfect form. A1, remember we had this A of n equals A1 R to the n minus 1 power. Okay, that was yesterday's formula. So here's what I know. I know A1 is 6. I know R is 3/5. Now because R is 3/5, it's going to get smaller and smaller. We can make this. You could actually put it in plug in 1, plug in 2, plug in 3, plug in 4. You can keep making it, but the thing is I know for sure it's going to get smaller and smaller and smaller because you're multiplying by a fraction smaller than 1. So here's what we're going to do. We're going to use our formula. S of infinity is going to equal A1, which is 6, over 1 minus R, which is 3/5. Do a little bit of math here, so I'll have really 6 divided by 2/5, because 1 minus 3/5 is 2/5. I'm going to divide a fraction, so I'm going to flip it. I have 6 times, I'm going to flip that to 5/2, which makes 30/2, which is 15. So if I were to create this, plug in 1, plug in 2, plug in 3, plug in 4, and then add them all, because that means sum, I'd get an answer of 15. Okay, number 4. Number 4 is easy. You know why? R is 5/2. I don't even need to do this one. If I'm going to multiply by something bigger than 1, it's just going to get bigger and bigger and bigger and bigger, bigger to the point where it's just so big it just goes to infinity. So this answer has no sum. Okay. All right. Here we go. So that's about all I have. I will let Mr. Fredericks pass out the worksheet to you, the homework, and you guys can do the homework, and when he's ready, he'll put on the film.